I've been in Austin for about 20 years or so. For most of that, I've been an independent consultant. So I've do a lot of work in a couple of different areas. One is on a lot of my consulting work tends to be .NET and SQL Server architecture, performance optimization, that kind of stuff, which is completely unrelated to what we're talking about here. But I also do a lot of writing and speaking and stuff related to Windows Server and Hyper-V. And yeah, and so I've been a Microsoft MVP for for 11 years, and for most of that, most recently it was Hyper-V, but other stuff as well. Some stuff I didn't even know what those areas of expertise were, like Microsoft management tools and stuff like that. So I've got more information on my website, and if you guys have any questions that I can't get to today, feel free to email me, and I'd be happy to get back to you. So that's just a quick introduction of me. For the session, I really spent a lot of time on this because I haven't done a 1-hour presentation on this topic well, ever. And so, I was trying to figure out what I think are some of the coolest features in Windows Server that you guys might be interested in. And so I wanted to talk about kind of this idea of software-defined storage and software-defined networking, and then talk about what that really means, looking down as how you're going to do standard data center management and IT stuff, now and going forward. So I've kind of organized it into kind of some technical sections, first talking about networking, then about storage. Then just a little bit about Hyper-V specifically, and then talk about what all that means for how you manage your data center, how you build fabrics and stuff like that, different approaches to it, and the pros and cons of those. So unfortunately, I think this topic is not that easy to demo, so I'm not going to demo anything. But I did want to mention one thing. How many of you guys have used TechNet Virtual Labs, Microsoft's learning? The only few of you? Okay. I found that to be extremely useful. If you just do a web search, you'll find TechNet Virtual Labs. Within one click, in roughly 25 seconds, they'll spin up an environment for you with 8 VMs. I mean, there's one that's just an intro to System Center, one for everything. You've got SCCM, Operations Manager, Virtual Machine Manager, all that stuff. If you've ever tried to set this stuff up in your own environment, you know how long that can take. And it's very rare to get it all right the first time. And so it's really cool, and I use that for some of my screenshots here. So if you guys haven't checked it out, there's dozens of virtual labs out there. One of them that I clicked was SQL Server Always On, the availability groups. It spins up a DC, 2 SQL Server computers, a scale-out file server installation with a full cluster shared volume implementation, all within 20 to 30 seconds. So cool stuff out there. So if you ever want to demo any of this stuff or whatever, there's no cost to it. I think it's really convenient. So that's out there. Okay, so let's get started. I've got a lot of content here, but it's not going to break my heart if we don't go through it all. So if you guys have any questions or want to discuss any of this stuff, or you're like, hey, that sounds great, but in the real world, this kind of stuff just isn't working for me or whatever, feel free to ask questions, and we can make this as interactive as you want. So what problem are we trying to solve? Really, a lot of this stuff, I try not to sound too marketing-y here. I was going to put up a joke slide here. When I get these slide decks from Microsoft that I adapt, they usually start with some CIO from General Motors talking about how he saved 23.2% in operational efficiency and CapEx is down 12% or whatever. And I'm like, to me, I just tune all of that out. Like, it's just not interesting to me at all. And then, I don't care about Gartner Magic Quadrants and that kind of stuff. In most of these presentations, when I see them, I tend to focus on that rather than the how are you actually going to implement or deploy this stuff. So I'm going to try to focus on the latter. So, if you're talking about it, like what are the general problems, all of you guys here do systems management are probably pretty familiar with this. It's kind of the crux of IT. Everything from planning, people change their minds more often than they change, socks, I guess. It's really common for people, for legitimate reasons sometimes, for poor planning reasons others, that you really need to adapt your infrastructure quickly. Changes in system requirements. That app that had 20 users now has 0. And then another app that had 100 users now has 1,000, and maybe you didn't build your infrastructure for that. So scaling quickly and efficiently is important. There's lots of problems with manual processes, right? It's error prone. You need to have specific knowledge. The one guy that sat in the corner that in a closed room that assigned IP addresses for your servers. He quit and or died. You never know. And now you can't get you don't know how that stuff was managed. So this is a big problem I see in lots of environments when I go in as a consultant. Of course, training and knowledge. There's just so many apps and stacks out there, and they're so complicated. It's really hard to have expertise in all of those. So either you look for consultants that have that expertise, or more often you just hack your way through it somehow and just hope it works. And then finally, of course, budget constraints, right? So hardware, resource utilization is a big thing. You don't want to have all these servers and systems that are just sitting there unused. So So server virtualization took care of a lot of that stuff. It hadn't handled hardware consolidation. It's an easy sell now, rather than 3 or 4 years ago where people asked, hey, can I run that in a VM? Now you need to make a good business case for saying you want to run it on hardware, right? Because it's generally a standard approach. Well, with that, we got a lot of things. We got workload encapsulation. We got portability. Everything works in a VM. If you want, you can actually do all of your disaster recovery in HA all consistently. So I don't have to have a different method for Exchange or SQL Server or some third-party app stack that I probably don't even understand. So I think of this software-defined stuff and this cloud stuff, regardless of the marketing terms and how people are using them. Really, this is the next logical step in the evolution of what would you do once you've got server consolidation, once you've got kind of the computation and CPU consolidation. Where do you look next? And what you look at is what are the manual parts of your infrastructure that you still manage, and often that's storage and networking. And so it's not uncommon to go into an environment where literally there's just like one guy, or one person, and you ask him or her if you want to set up a new LUN. And then they go through some management UI, they're an EMC expert or a NetApp expert or whatever, and they go through, create a new LUN, assign it to you, attach it to your VM or your host, and you use it. There's a lot of manual steps in that, and often I see all the time people are like, hey, SQL Server, I heard that you shouldn't put your log files, transaction log files on the same volume as your data files. How many people have heard that? Like everyone? Yeah. But it's a little simplistic, right? So people will be like, oh, I'll create 2 LUNs. They're all going to the same SAN, on the same network, on the same fiber channel architecture. And there's just no benefit of that, right? You just get the same amount of contention. You just have 2 LUNs instead of 1. So there's a lot of issues where the complexity of those application stacks is high enough where people often don't get it right. So along with that, you need repeatable processes, so they have to be scalable and consistent. So if I need 10 instances of, let's say, a WordPress deployment, I would need to make sure that the whole stack, the PHP stuff, the MySQL database, everything is configured properly and consistently. I say often to my clients, I'd rather something be done consistently wrong than have some instances of it done properly and some not, because I can troubleshoot the former. The latter can be a lot more complicated. Interdependent infrastructure. So now when we talk about deploying apps, most of your business apps, they're going to have requirements on different things, usually messaging, of course, Active Directory probably, the network stack, of course, some storage requirements, and almost always a database or some persistence layer of some sort. So all that stuff has to come together in order to be able to successfully deploy this. And of course, reliability, we'll talk about availability and performance. So these are kind of in my mind, what software-defined infrastructure is the problems they're supposed to solve. Did I miss any pain points up here? Anything else that? Okay. So this is, so what are the requirements for the solution? It has to be manageable. I won't go through all of this in detail because you hear it all the time. You're talking about SLAs and quality of service, uptime, security, all that kind of stuff. And we'll address each of these as we talk about the actual technical details. If you look at cloud service options, in general, you hear these are the terms du jour, the software as a service, platform as a service, and infrastructure as a service. The most efficient way, and a lot of people don't think about this, they say, hey, I want to consolidate, I've got 3 SQL servers and I want to consolidate those. So boom, 3 VMs, right? Or I've got 4 IIS servers and I want to consolidate those 4 VMs. That's often the least efficient way to do it. It'll work, and might be the safest, especially if you don't have knowledge of those applications that are running. But really, a SQL Server database a single instance SQL Server can handle hundreds or easily dozens to hundreds of databases. Your better consolidation approach might be put all those databases on the same server, unless you have a specific reason that you can't. So kind of the point that I want to make here is, you want to virtualize or use your cloud services at the highest level possible. So for example, if I go to the Windows Azure or Microsoft Azure portal and I say I want a website, there's a lot of different ways I could do that. Let's say I wanted to create an ASP.NET website. Well, I could say provision me a VM and set that up for me, and then I'll configure IIS and everything, right? And that'll work. Or I could say, at the platform side, I want to run, let's say WordPress, or I want to run an MVC app or something like that. I could do that at a platform level, or I could even do it at the software level. Say, really, I don't care where it's hosted. I'm just going to use this application, as a software. Host everything. I don't really care about any of it. But the point is, go as high in the stack as you possibly can. Any questions there? Okay. How much of this? Anybody think this is going too slow? No. Okay. No. Too fast? No. No. Okay. All right. Just making sure. Okay. So let's talk about the technical stuff. I'll talk about Windows Server 2012 R2. So there's a lot of main core areas in what's involved in the server platform. And it's really an interesting time, I think, for Microsoft because a lot of the stuff that they're building is their software and services stack that they need themselves for the Azure platform, right? So they need things like a scale-out file server. They need high availability without calling EMC or some of the tier one vendors, where 6 digits is where the pricing starts for their low-end solutions. They need things like, we'll talk about network virtualization and encapsulation and stuff like that. Well, the cool thing is they're also building not all of it, but most of it into their automation platform in the form of things like the Windows Azure Pack. How many are familiar with that? Yeah, for Windows Server. So basically if you're ever wondering what the UI for this looks like, it basically looks exactly like Windows Azure when you go to the Azure portal, the old one at least, the old Azure portal. And so you can have all of the types of automation and stuff that Microsoft uses to provide to the world, to provide either to your own organization, or if you happen to be in the hosting business, to your own clients. So there's lots of requirements, to get that to work. A lot of pieces have to come together. One of those is probably lowering your blood pressure when you think about the fact that you can have multiple isolated environments all in the same fabric, sharing the same storage, sharing the same networking and stuff like that. So that's what I'm going to focus on here. Okay, this might be kind of hard to read. It's kind of an eye chart probably. But just on the networking side, if you look at this kind of stuff that was, most of the stuff was in Windows Server 2012 and then improved in R2. But things like NIC teaming, I'll talk about SMB 3.0, the protocol, and these are going to be kind of the puzzle pieces that we're going to use to build the infrastructure that you can use to trust these scenarios, software-defined, managed environment. Just to take a very high-level view of this, I think if we were to start IT all over from scratch, we don't have any requirements, no x86, no spinning disks, we're not even thinking about any of that kind of stuff. How would you design stuff like this? Well, I imagine the ultimate thing would be you just have one pool of capacity, just like we think of maybe electricity, right? And back in the day, there were lots of companies that made their own electricity, but now you don't typically. Usually only a few companies will do that, and it will use those services. Well, the idea is think of your data center the same way. It's one big pool of capacity. I have an app, I just throw it in there, just like I would plug something into an electrical socket. If I have a requirement for a complex network stack that requires 12 VMs and distributed architecture and an Active Directory and a domain controller and all this other stuff, I just throw it into the pool, and the pool manages itself. It says, oh, it goes over on this host because that has the most CPU capacity, and it uses storage at a silver level tier because it doesn't need high performance and that kind of stuff. That's kind of what we're talking about. We're not there because we really are in a state where there's legitimate reasons to support 20-year-old software still. I mean, there's stacks, custom applications that people use that still need to be supported, like it or not. So what'll get us there is, one part is talking about software-defined networking. The term software-defined, you can kind of replace that with saying dynamic, meaning the idea is, rather than looking at physical network switches and firewalls and VLANs and things like that, you build a layer of abstraction on top of that where you can basically do any kind of network addressing you want. So right now the problem is, let's say without looking at this type of solution, if I want to host something on Azure, I'm probably looking at using a separate IP address namespace, right? So if my data center is using, let's say, 10.x.whatever, 10.0.0. whatever, and then I want to put those VMs up on the Azure side, I'll probably need to readdress them, and then I'll probably have to do some kind of routing between Microsoft's data center and mine, right? Or some kind of encapsulation layer, either through a VPN or something. And that becomes a big problem. And then imagine, if a lot of different people want to use the same IP addresses. Who has this problem? Well, Microsoft, for one, right? They're hosting hundreds of thousands of people that might want to use the same address spaces. So what is software-defined networking? It actually puts an abstraction layer above your physical network switches. I'm not talking about VLANs necessarily. This is layer 3, a layer 3 type of readdressing of the network. And what it looks like, or what it allows you to do, is basically you have a provider address, which Microsoft in their implementation calls PA, and then a customer address is CA. So in this case, you actually have running on one physical network. So imagine this is just one physical set of switches or however it's configured. You actually have two separate networks that are using the same address. So in this case, there's a blue network and a red one. Neither one should have any permissions to see anything on the other network. But notice that they can use the same addresses. So here we're using .12 and .12 for two different devices.
So is this like a ReNAT on a source and destination header?
Good question. Yeah. So how does it work? Like, is it a NAT or ReNAT? No, it's not.
This looks like it's hitting it at the edge on both sides.
Yes. So this is overly simplified. because it doesn't even tell you what layer we're doing here, right? We're doing layer 3. This is not NAT. This is actually going to be GRE.
Okay.
So yeah, routing encapsulation, generic routing encapsulation, is that what it is? Okay. Yeah, so it's network virtualization, generic routing encapsulation. It is similar to doing, it's not similar to tunneling, it's similar to rewriting routing headers, right? So yeah, so I have a lot more detail on this, and that link, I'd be happy to send this if anybody needs it, the links and stuff when we're done here. So we'll dive down into it a little bit more. Every time I've seen this presented, and every time I've had it presented to me, there's so many questions on how this works. And the general feel I get from people is they're like, that can't possibly work. You know, this can't, it just doesn't, it seems like it's too good to be true. So, but it's not, it does work. I've definitely set it up myself. Okay, so what does this look like? I think this is a build slide. Let's see. Yeah, so what's really happening behind the scenes is you have the provider address space, and that's actually going to be your physical network infrastructure. That's what your actual switches and routers and everything are configured, how they're configured. But then when you actually build networks on top of that, you have a private customer address space. Okay, there it goes. So yeah, you actually look at what's actually happening in there, and basically what Hyper-V, and we'll talk about that architecture, the Hyper-V virtual network switch is doing, is actually handling the translation at the virtualization level. So there's a couple of different ways you can implement this, but the one that Microsoft wants you to use is System Center Virtual Machine Manager. And so how many people have used that where you define your networks in Virtual Machine Manager? Yeah, and a couple of you, okay. And so you can actually there go in and say what that address space is that the VMs are seeing on the inside, and then how that maps to your physical infrastructure. So another question that a lot of people ask is, well, why not just do this with VLANs? Does anybody want to answer that? Why not just create a bunch of VLANs for each of your virtual networks? Well, one, that's a lot of management, right? That's a lot of pain. You run into things with collision domains that can be too large, and you sometimes deal with issues where the numbers still have to be consistent because they have to be able to communicate across VLANs sometimes and things like that. It's just a lot more work. And of course, if you have VLANs, you can't have these servers and devices would have to be then readdressed. Their network addresses can't be the same. They can't be identical. So this actually happens all, again, software defined, and how it's implemented. Well, anyway, what's being shown here is, again, you've got two networks, a blue network and an orange network. What they're showing here is both of them are seeing the same IP addresses. So this is all I care if I'm a subscriber to like Microsoft services, or if I've set up Azure services in my own data center. I don't care that, you know, down below on the physical layer that it's using this 192.168 address space. And it's really the responsibility of the network translation layers that handle that. Okay, this is even more detailed with lots more numbers. How many people get the general idea that we're talking about here? Yeah.
What's the use case though? I mean, is the use case that you typically see a dev test prod environment, or is it true multi-tenant, or I mean,
yeah. So there are several, and the less common one is if you are a hosting provider. Right. So that one, okay, maybe that one's obvious. But dev test prod, that might be an issue, but really what the idea that I want here is I want to take all of the requirements for a stack, an application stack. That means the storage, the networking stuff, the VMs that run it on the software, and encapsulate that. So I can throw it wherever I want to throw it. I can throw it in your data center and without reconfiguration, or I can throw it in a portion of my data center or relocate it, or ultimately I can actually tell Microsoft, hey, you go ahead and run this stuff for me. But I want to be able to do that without having to readdress, handle the readdressing. Yeah, and so
I want to make sure I'm capturing this correctly.
Yeah.
Because I think I have an example. And I want to make sure that I got this correct. I
Sure.
can't tell you who it is, but it was a client that I was working for, single client but multi-tenant.
Mm-hmm.
The multi-tenant divisions of the client were individually siloed. They
Yep.
all used the 10.0.0.0/8 address.
Right.
They were coming into a consolidated data center, at which point they were literally readdressing them at the edge. But they ran now. Here's a piece that I want to ask about, because they ran into a situation with a particular software app,
Right.
Specifically Net Backup.
Okay.
That cannot do because all the master servers were hosted in the data center, as were the deduplication devices and the offline storage.
Right.
When a restore request came through, it could not determine where to send it to because all that address translation was lost once it was put into offline storage.
Right, and often you'll
Does
have
this help that?
Yeah. And in that case, so a couple of caveats with that. So I understand the problem. In fact, when you're talking about like a backup network, for example, you often have separate addressing for that that's completely separate. Like you'll have multiple ports on your servers, right? And then you'll have a separate backup network. And so there's a couple of requirements here. First of all, none of this applies if you're not talking about virtualization. So in your case, were all of those workloads virtualized?
Not all.
Probably not, right? Because if you're doing a backup, I imagine that's a backup tool, backup and recovery tool.
Correct.
So in that case, you're probably backing up and restoring to metal, like to
Correct.
hardware. Yeah, and so in that case, then this kind of stuff doesn't apply because those workloads won't be portable. And the reason for that is because if you have nothing running on that machine, it needs to be able to do a full restore from the stack up, network stack up. So yeah, so in that case, it wouldn't apply. But that's the point, and that's the point in saying that's one of the benefits of moving to virtualization. The same you could say, for example, taking a virtual machine that's a very complicated configuration, and if you wanted to move that complicated configuration somewhere else, if it wasn't virtualized, it would be a lot harder, and then you probably would have to do a lot of the manual readdressing. Does that make sense?
Yeah,
Okay.
I was trying to get around
Yeah.
the solution that we had to come up with, which was for the pieces that couldn't be translated inside, we had to create that master server inside
that domain.
UCS stack.
Yeah,
And then have it travel across their VRF so that master server was in their own VRF before it was offloaded.
Right.
And the offload could come into that stack
Right.
and then go out along that VRF. So
Exactly, and what happens a lot with that is, people look at it and they say, well, really, do these multi-tenant solutions, do they have to have overlapping addresses, right? And often the answer is no. I could readdress everything so that it is compatible, but that's a lot of work and that's a lot of risk and it's a lot of change. And then what if I have to do that again? 2 years from now, I'm actually going to outsource that to a public cloud provider or something, and then I want to move that stack. You'd have to go through that same pain again. Yeah, so it is cool stuff. I mean, and there is this kind of feeling I always get when I was talking about it. It feels like it's too good to be true because it really takes a lot of the complexity of the manual administration of network management and moves it up to a layer where before, if you want to set up a new server OS, you're typically calling a hardware vendor. You're going to rack it. You're going to plug everything in. You're going to make sure you have enough switch ports and all your management tools. Now you basically use a gold image and just spin up a new VM. Well, it's the same kind of idea here on the network side. So yeah. Good. So how does it actually work? This is probably going to be too hard to read. It's probably too small to see. But this is actually part of the architecture in 2012 and 2012 R2 Hyper-V, where there's actually virtual switch extensions. If you can see this part, this is on the left-hand side. This is Windows Server 2012. This is R2, which changes the architecture a little bit. But the part that matters is this. So you've got a Hyper-V network virtualization portion in there, and this is where the address, I want to say address translation, but it's not NAT. I don't want to say NAT, but this is where the address management is actually handled in here. Notice there's also third-party extensions. So if you want to write your own packet filters, and a lot of people do, they all have things like for security purposes or for compliance checking and things like that, they can actually add your own extensions here through this API, and that would be fully supported by Microsoft. Okay, let me just ask this: who's not confused? Anyone not confused? Just one? Okay, my job is done here. The idea here is basically the high level thing that we're talking about is basically adding a layer of abstraction to the environment, like you did with computation stuff, but doing it for network. And we're going to talk about doing it for storage in just a moment. This is stuff I think you're going to hear. I'm going to skip through a few of these. That you're going to see a lot more of as you go forward. So I can't comment on specifics, but with future Windows Server platform stuff, you're going to see a lot more work going into this area. Okay, so let's talk about this kind of the crossover between networking and storage. How many people know the difference between like a file-based storage access versus block-based? Like iSCSI versus your file share SMB. How many would like me to explain the difference? Kind of. Okay. So really, when you look at actually accessing storage, there's a couple of different ways that you'll do it. One is your standard Windows file shares, / server name, / share name. And that protocol uses server message block, Microsoft's implementation that's been around now for 20 years or more. And basically, that's the way that you access files, which is great for handling things like documents and things like that. But what it's not great for, or wasn't great for, is doing things like, can I store my SQL Server databases on there? Can I store my transaction logs on there? Can I store my virtual machines, my VHDs on that? Well, traditionally what you would do with that is you would use your SAN. You would use either iSCSI or Fiber Channel, and that was block-based I/O. it's exposed to the server as if it's local storage. In fact, unless you're trying, the server can't tell whether it's local storage or not. So it can do every disk operation you could do with local storage, defragmenting the disk, formatting the disk, using any file system you want, those kinds of things, snapshotting and things like that at a file server. Well, the problem that is happening, Microsoft looked at it and they said, hey, well, why do people separate those two things out? Because if you actually look at the cost of it, block-based storage is extremely expensive, like 100 to 1,000 times more expensive, especially if you're buying non-commodity hardware. You know, you're buying disks, or you're buying from a vendor that says you've got to buy the disks from us, you know, and stuff like that, which is very common with your tier 1 storage vendors. And so Microsoft said, well, that's not scalable. It's not financially scalable. We can't afford to be paying this much for storage just to have reliability and performance and compatibility with our workloads. So this is Server Mesh-Struct 3.0, which came in Windows Server 2012. I think they call it 3.1 in 2012 R2 with some improvements. So what is the goal? The idea here is use a file-based protocol on your standard Ethernet copper connections, or whatever your network is, 10 gig or gigabit Ethernet or whatever, but give us all the things that we expect from a real SAN. And do this all with stuff that's in the box in Windows Server and doesn't cost anything extra. So let me go down to Fry's and buy a stack of disks and just use that with fault tolerance, automatic failover, multipathing, everything that I need to run enterprise level storage. Again, when I first heard this, I was like, yeah, this is too good to be true, because you know it really could potentially upset that whole industry of the storage industry. Well, let's look at how they did it. So some of the features in SMB 3.0 is scalability via shared storage, cluster shared volumes, or CSV, now supports a wide variety of different workloads. So before, Microsoft was really scrambling, originally when they came up with it, to come up with a solution for to compete with VMware's vMotion. But they've gone way farther than that now. And then now they support everything, SQL Server databases and stuff like that on cluster shared volumes. That is a shared storage solution. So you think of it as multiple servers that actually connect to a storage array, a disk array of some sort. And if one node goes down, the other node can take over. That would be an active-passive situation. Or active-active, which is true active-active, where multiple nodes can access the same storage at the same time. Better yet, I'm doing a 2 terabyte file transfer from one node, and that node goes down. I can resume that transfer. The client is told, hey, those bits that you're getting over the wire, that guy's gone now, just take it from the other cluster node. And this all works all in the box. It's all configured as long as you have the right architecture for it. So SMB multi-channel for performance and failover. So this gives you automatic failover even in the middle of a session transfer. SMB direct, so this is actually an offloading type thing, just like you have tow cards, TCP offload engines on your network cards. This actually allows you to do it on SMB. Encryption, so that's really important, especially running in hosted environments. Now, increasingly, and sadly, most people are starting to run that in their own data centers too, because they can't trust those networks. But encryption is really important. And yeah, and I mentioned transparent failover as well. What else? Okay, so the idea behind this is the standard protocol that you've been using for file shares can now be used for a whole bunch of different stuff. And that means enterprise mission critical workloads, things that can't survive 20 milliseconds of downtime, things like that. We'll talk a little bit more about what those requirements are after I talk about which features we have. How many people are using the IP address management, IPAM features in Windows Server? Anyone using this? A lot of people don't even know it's here, but it's a standard server role that's installed in Server Manager, and it basically is a distributed IP address management solution. I guess I don't need to get too much more into that, but that's for handling complex networks. Okay, NIC teaming. So how many people typically use NIC teaming for your servers? Yeah, most of you, right? And the big problem with NIC teaming, I wonder if that's ever going to stop. This is how good it is, right? It sees high availability. It's going to keep going. The big problem that I've run into with this is that you could end up having a problem with 2 different NICs that are actually not compatible. Actually, 2 NICs from the same vendor with the same model number with different firmware revisions, and somehow the transparent failover isn't working, right? Or some people call NIC teaming, they use it for failover, but not for bandwidth aggregation, right? So I could use it, but there's just one network port just sitting there, not doing anything until one fails, and I fail over to it. Well, for all those reasons, a lot of people either didn't use NIC teaming because they thought it was too expensive, or they would only use it for the most critical workloads. But the good news is, in Server 2012, the actual network drivers that ship in box that Microsoft supports are actually vendor agnostic. And so they're available for you there. So this allows you to do a couple of things. One is, of course, set up NIC teams. I guess 32 network adapters are supported, so that's a lot. It's both for failover and for bandwidth aggregation. It can work across different vendor network cards, which is a real plus. And the other benefit is it's the basis of multipathing. How many people know what I mean when I talk about multipathing? Yeah, a few. Okay. The idea there is completely separate infrastructure. So if I really want to have full network redundancy, I need to be able to not just have separate network cards, but also separate network cables going to separate network switches that are going to separate segments. The idea being if one of those, any portion of that infrastructure on one side gets interrupted, the other one can take over automatically. Right, so the other one, it can fail over to that other network. I can also aggregate bandwidth by having two different routes or multiple different routes to the same storage. If one of them becomes a bottleneck, then I can get the bandwidth from the other. Okay, okay, so NIC teaming. Oops. Okay, I'm going to skip through a little bit of this for the sake of time. Okay. All right, so let's move on from networking to storage. And SMB 3.0 is kind of I think of it as in both places. Bunch of features in Windows Server 2012. It's probably, I mean, one of the biggest and most complicated releases that I remember that Microsoft has ever done, probably since Windows 2000 with Active Directory. So all this stuff ships in the box, and it is available in all editions of Windows Server. And so let's talk about what these are with the idea of software defined, how these things can help you actually encapsulate your workloads and then be able to move them wherever you want to move them. Okay, so one thing that I often have questions from clients is, when I'm collecting storage requirements, I'll say, what kind of I/O do you need? What kind of I/O per second, and what kind of I/O do your apps do? And usually they have no idea, which is fine because usually, in the days of direct attached storage that's, dedicated to a server, you didn't have to worry about contention. You just had the maximum performance of that disk. Now, that's the upside. The downside is you probably weren't using the maximum performance of that disk, and it's costing you a lot for just sitting there not doing anything. So how do you get your storage requirements? A couple of different ways. Synthetic benchmarks. So you can, there are lots of places that do those online, and you can find out, how fast is this SSD compared to this RAID 5 disk array or 0+1 disk array or whatever. So the benefit of those is they're consistent and repeatable. So I can give you a number. I can say I can get a peak 300 megabytes per second sustained throughput on a sequential read, something like that. So that's good, but it often doesn't map to real world usage. How often are you really doing a sustained sequential read? Probably not that often for a lot of apps, unless you're streaming video or something like that. The second way to get storage requirements is through load testing. And so the idea with load testing is that you actually artificially create load on the system and see how it reacts. Find out where the bottlenecks are. Is it network? Is it the storage itself? Is it the disks? That kind of stuff. And then last but not least, those of you guys that use the system center stuff, Config Manager and Ops Manager, you can use historical performance. So go back into the logs and look at what do these apps really use in the real world. And that can be the most accurate, but it's sometimes if you're not collecting that data, you don't have it. Okay, so why is this important? There are a lot of different advanced storage features that this can map to. So you might find that you want to do file system level snapshots. There's different RAID levels that you might choose, clustering, failover, all those kinds of things. And then on the performance side, data replication, between data centers or between storage arrays on the same rack even sometimes, or multipathing. Like these are all going to tie into your requirements. And then management, the ability to easily add storage as you need it. And then finally, storage tiering. And I think I have a slide on that. Okay, I don't. Storage tiering. The idea is, you go into a lot of environments and they treat all storage the same. Everything runs on fault-tolerant hardware, really expensive disks and stuff like that. Well, the vast majority of what you run doesn't need that. The vast majority of your stuff can either be rebuilt or very cheaply and very quickly, or doesn't need to be on the highest performance hardware. So the idea behind that is saying, okay, I'm going to have 4 tiers of storage. One is going to be for maybe end user data, and another is going to be for mission critical databases or transaction log files or my Exchange database, and some levels in between. And so the whole idea behind this is making the most efficient use of storage resources. Okay, so don't just buy what you need and apply it in the best way possible. Okay, the last storage-related feature I'll talk about is scale-out file server. How many people are familiar with this? Maybe not the term, but highly available Windows file servers. Yeah. Are you using it for general user file shares? Or?
I'm not using it, I just know of it.
Okay, and it's a new idea. I mean, typically people would think, okay, file shares, that's great for user data. You know, if a user can't get to their Excel spreadsheet, they might be annoyed, but it's not going to bring down my company. So they used to use file services for that kind of stuff, but then use SAN-based storage for everything else. Well, Microsoft again said, well, what is keeping people from using using your cheaper, more readily available file server stuff for enterprise mission critical workloads? Well, SMB 3.0, reliable protocol, was the first thing, and the other was being able to have full active file shares. So there's kind of two different modes when you set this up with in cluster services. You can actually set it up as a general file server, which is a single node is active, and it's a true shared storage solution. Multiple nodes connect to the same storage, but only one's active at a time. And that's fine for some scenarios. But in other scenarios, what you really want is active file shares. So that's what I was describing. You have multiple server nodes connecting to the same storage, all of them servicing requests at the same time. They can trade requests between them to balance load as needed. And just basically what you would expect from the highest end SANs, basically that kind of stuff. So the main key here is it's for use with not just your standard Excel spreadsheets and user data, but also Hyper-V. So your virtual machines can fit on there. System Center Virtual Machine Manager itself can use that as their library, as your VM libraries and things like that. SQL Server, your Exchange data files. Basically, it's a SAN in a box, and there's no extra charge for doing that. Okay. Okay, so there's a couple pieces of this puzzle. How many people use storage spaces? Well, no? Okay, a few. I do. Well, in my home environment, I use it, and I have clients who've used it. The idea behind this is everybody looks at kind of what it says, and the first question it says, well, isn't that just RAID? Well, it's similar in concept. There's the ability to take multiple independent physical devices, and they can be commodity like your SATA hard drives or your shared serial attached SCSI devices, but treat them as single logical volumes. So in addition to that, you can do it without parity, without redundancy, or you can choose to use what's typically the RAID 5 type model with a single parity, or you can use double parity, dual parity, as long as you have enough disks to do it. So that's the N-way mirroring, multiple way mirroring. That's actually aggregating your physical storage into storage pools. So those pools can then be divided up into storage spaces. And these storage spaces, you can have different pools. For example, you can have a pool of SSDs for your highest performance stuff. Then you can have a pool of SATA drives for your just backups, for example. Your backups don't need to be on tier 1 hardware typically. And so then you can carve that into storage spaces, and then the storage spaces then are served up through all of the different features of Windows Server. So it could be a cluster of shared volumes that you create on the storage spaces, or just standard NTFS volumes, Hyper-V volumes. You could just do your virtual hard disks on that, etc. Okay, and then finally, you can expose that to your users as through an application server or file server, a Hyper-V host, or just a standard file server. Okay. So the idea here is all of this stuff, again, doesn't require any specialized hardware for it, but it's a better way to be able to manage your storage and carve it up the way you need it. Okay. And so this kind of reiterates the importance of using SMB 3.0. So just using SMB, what ships in the box, with Windows Server rather than proprietary protocols or optical connections, fiber channel connections, which obviously are much more expensive. Okay, I talked a little bit about storage tiering. The idea here is, yeah, it's great if I know, how hot or cold my data is, what stuff is actively used, and then I'll just move that to the fastest storage, and then the stuff that gets stale, I'll just move that to slower storage. I could do that manually, but that's a lot of work. Storage tiering in 2012 R2 is automatically built into the OS. So you can even, it'll automatically take a look at cold data that can be moved to slower drives, and move that off to slower, cheaper storage. And you define how that storage is for you, if it's cheaper or whatever. And then automatically move the hot data to faster things. So when you start looking at SSDs or SSD arrays, you can actually move that up quickly, automatically. But you can override it, of course. So you can pin high priority files. Maybe there's files that aren't used very often, but when they're used, they better be fast. So that's important. Okay, so yeah, so an example of how you might do this is you use your storage spaces to combine your different types of storage, and it could be they don't have to be the same. So SATA drives, just a bunch of disks, SSDs, whatever, and then you expose those in different tiers of storage. So I guess in this case, marketing just doesn't matter that much. So so that one's using the slowest, cheapest storage. But man, you better get finance right. So they've got that with the highest skill level here. Okay, so really get the concept of storage tiers. Yeah, the idea. And so again, the idea is make the most efficient use of your infrastructure, but also make it portable, so you can reconfigure your environment without having to go to a rack, buy new hard drives, plug those in, and add them to an array or resize an array, that kind of stuff. And then they actually threw in, of course, Microsoft Azure itself, right? So Microsoft acquired a company called StoreSimple. Those products are pretty expensive. They start at like $75K or so. But the idea there is this cloud integrated storage. It automatically does block level differential backups to the cloud for you in that device. So obviously you can roll that yourself. You don't have to buy that product. But from what I hear, it's pretty popular with mid-sized businesses. Okay, last technical area I'm going to cover is the Hyper-V side. So I just have a couple of slides on that. And how am I doing on time? How much do I have?
I think you're good for a little bit, yeah.
About 10 minutes?
10, 15.
10, 15? Okay, cool, good. Awesome. Okay, so what do you have? I'm not going to show all the details about this. In Hyper-V, larger virtual machines, probably way larger than you would ever need. I think it's on the order of 4 terabytes of RAM per virtual machine. Pretty good. And I don't know what the number of processors is, but I also think that's like in the thousands. So really, that's no longer an issue. People can't say this workload is too big to run and virtualize. That shouldn't be a problem. The overhead is now in the low single-digit percentage for CPU overhead and memory overhead and stuff like that. So the idea is removing the barriers for saying, hey, I can't run this in a virtual machine. You better have a really good excuse now, because there's a lot of stuff that there's not as many blockers. Live migration, so this is very critical to software-defined stuff. Automatically, if you think about the high-level goal, a whole pool of machines that automatically balance the workload themselves. I don't deploy a virtual machine to a host. I deploy it to my data center fabric, and it figures out what storage is needed, which host that should be on. It might be on one host in the morning on Monday when it's being used, might actually move to another host in the afternoon, all live, all in real time, and without me doing anything. That's what we're talking about, just automatic rebalancing. One thing I will talk about is shared nothing live migration. So the idea behind this is to actually I could do it with these 2 laptops. I could basically set up an entire failover cluster on these 2 laptops, if they were running server OSs, they're not. But if they were running Windows Server, and I have done it on 2 laptops, where I can do full high availability with just one Ethernet cable. Right, so that's basically, I use a shared SMB solution, SMB 3.0 protocol. I have my virtual hard disk sitting on that, and I actually have, in that case, it would be a 2-node cluster. I could do live migration between the 2. Again, everything with that is something that would ship in the box. With Windows Server 2008 or 2008 R2, you'd probably be looking at a third-party solution that would probably start around 25K, I would think, to do that. So it's a really cool feature. Some new stuff, dynamic memory. So automatically, Hyper-V, while the virtual machine is running, it can actually reassign the amount of memory, the amount of RAM in it. So I don't have to do a pause or stop. I can change that level of memory commitment as needed. So often what Microsoft has found is you can actually run Windows 8 with 128 megs of RAM. It's not much, right? The trick is you can't boot it with that. So you actually need more space, and a lot of that has to do with firmware stuff, loading into the BIOS and everything. So what they do is the default settings for a lot of these virtual machines is give it up to, let's say, 2 gigs of memory. You give it to that on boot, but usually within about 15, 20 seconds after boot, it can give it back to the OS. Add that in with the idea that saying, hey, if I do run out of RAM, I can move it to another host without any interruption in service. And now you've got a really dynamic environment. So some other things that are built in, some very basic resource metering. So for example, if I want to bill back or just at least show my organization how much my marketing department is using in resources, that's just also built in and accessible through PowerShell. Okay. So live migration, how many people are familiar with Hyper-V live migration? Yeah, so most of you at least aware of what it does. There is a new generation 2 virtual machine. It's UEFI based, so it's actually got a different BIOS. And this actually is designed to solve some of the problems of the old BIOS architecture, which is really, I think, about 30 years old. I mean, it's a pretty old standard. There is no compatibility or migration path between standard virtual machines that are BIOS-based and Generation 2 virtual machines. So there's no automatic conversion, but both are available. Anybody using Gen 2 virtual machines? No? Okay. And I think what you probably see is a lot of people, as they create new virtual machines, they'll make them Generation 2, But there's not a huge compelling reason to do that right now. Okay. And I'll skip a few of these. Okay, quality of service. Imagine, if you will, that slide stayed up. Quality of service for storage. That says that I can actually say that this virtual machine can't dominate my disks just because I have an app that's not running properly or a SQL database is not configured properly. I can actually put in a quota and say it can only use this many I/O per second or this much storage bandwidth. So make sure that, I mean, one of the things is if you're going to throw all of these different workloads into a pool, they have to be able to cooperate with each other, right? Because they're not aware that inside a virtual machine, it doesn't know if somebody else wants that storage. It just tries to take everything it can. So it's really good to do quality of service type things. How live migration works, there's really two things you need to move. There's the persistent storage, that's your virtual hard disks, and then of course the memory, the volatile stuff. So this slide just shows it, how those actually happen, and you can do many of those concurrently. It's really, now it's only hardware based. It's based on your network throughput and your storage throughput. Okay. Okay, and I already talked about shared nothing live migration. So yeah, it's just the point here is it's just an IP connection, just an IP network connection between the two. No SANs, no fiber channel fabric, no special requirements on storage. Okay, so let me. I also talked about dynamic memory. So there's a lot more. There's a lot that goes into dynamic memory. I should have mentioned that that the OS, the client OS, has to support it. So I believe that's Windows 7 and later on the client side, and then Windows Server 2008, I think R2 and later can support memory ballooning without rebooting the server. Okay. Okay. So finally, let's talk about all of this. Bring it all together with the networking stuff, the storage stuff. How do you actually implement software-defined everything? And again, hopefully I've sold you guys on the idea of why that's valuable. Again, you can move your workloads around. They're easier to administer, automated stuff. Well, of course, System Center. So Virtual Machine Manager, you can create your fabrics, create your storage definitions, your storage tiering and levels and all that kind of stuff. Ops Manager and Config Manager, of course, and Orchestrator. Does anybody use Orchestrator? Oh, you do? Okay. What for?
Just getting started with it.
Yeah.
We're doing a lot with SRM to automate some of those requests coming in, as well as what's the word? Incident enrichment.
Okay.
So we add stuff to an incident.
Yeah. Okay. Right. Right. So it fits in with support tickets and things like that.
Yeah. Query remedy and
yeah. Okay. So use remedy. Yeah. Exactly. So and they can be as generic as you want. It's basically like a workflow type product. So you can have what they call runbooks, and those runbooks, again, getting to the idea of having repeatable processes. Here are the 12 steps it takes to, let's say, close out a ticket where somebody says, I need more disk space on my client, or something like that. So that's the newest member of the System Center family. Containers, anybody use Docker? Who's familiar with it? Idea? So it's containerization. Basically, the idea is, when we go back to my very first slide, I don't need to virtualize an entire OS just to be able to run a separate application stack, because that's a waste. Do I really need a whole hardware abstraction layer just to be able to run an extra website or whatever? Well, some people say yes, because it's so complicated that I could tell you how to configure it, but you'd mess it up, right? Containers are designed to solve that problem. Docker is an open source implementation of that, and it actually allows you to have containers that run within an operating system, a virtual machine, without running a completely separate VM. So way more scalable, way more efficient, but also gives you the benefits of encapsulation. It's a single command line. It's like a get, like you would do from GitHub or something. Get Docker package, and then whatever the name is, it installs on your system. Really light layer, uses a couple of megabytes of memory, and the whole stack is set up. So I think you're going to see a lot more of that. Microsoft has announced that will be in Azure as well, fully supported in Microsoft Azure Cloud. Vendor-specific utilities. So of course, your storage vendors, your network vendors have their own utilities. Some good, some not so good. For doing that. Scripting. So PowerShell, Windows Management Framework, and then of course you can build your own custom apps for doing that. This can be very painful, but in environments that want to put together the actual effort to do it, it can also be very valuable. So if you have the resources to do it. And then finally, cloud automation. So of course, the Windows Azure Pack I mentioned, that allows you to run kind of your own data center cloud infrastructure in your own data center. So users see an interface similar to Microsoft's Azure portal. They say, hey, give me a VM that's based on Windows Server 2012 R2, and just spin that up for me. Okay, so good stuff. what are the components of it? So there's the compute servers. So that's basically your virtual machines. So dynamic memory reconfiguration is important. VMM will do that. And of course, you can do it yourself through either PowerShell or through the Hyper-V GUI. And resource optimization. Move those VMs around. Don't put all of them on a couple of busy hosts and have everybody else just sitting around. On the network, automatic load balancing and failover. And then we talked about the virtual private network addressing, and of course clustering. And then on the storage side, things like data deduplication, caching, storage tiering, all that kind of stuff. All of those things are kind of the components that you need to really have a software-defined, I guess, data center or cloud. Some of the actual specific operations, and so this would be like a hit list of the types of things you might want to automate if you haven't already. On the deployment side, provisioning new application stacks. So that's not just copying a VM from a base image and sysprepping it or whatever you're going to do with it. That means actually setting up the storage, provisioning the LUNs, initializing the storage, making sure that the network connections are set up properly, making sure that if you need multiple network ports on your switches, that those are all part of that, and it's not just copy a VM over somewhere and then email the guy to give you a LUN storage. Monitoring management, so monitoring end user performance, make sure that all the steps in that chain, if there's a problem with storage, I mean, your users don't care if it's a storage problem or a network problem. They just care if they can get to their apps. So making sure you monitor that, along with SLAs. And then I've talked a couple times already about rebalancing your VMs to make the best use of hardware resources. So that's optimization. I mentioned the Azure Pack for Windows servers. This might be hard to read, but this is it's a self-service type management portal that Microsoft provides. It's free as far as I know, so you can download this and run it in your own environment. And it is that idea where you actually throw your resources at it. You say, here's what my physical network looks like. Here's what my virtual machine network looks like. Here's what my storage and databases look like. And then now that my users just go in there and request what they want themselves. Has anybody used this in their? Oh, you guys use it. Great, cool. Okay, and I'll just end by talking about Virtual Machine Manager. So this, how many people are familiar with creating storage fabrics and stuff like that in Virtual Machine Manager? Okay, well, you can. So that's what this is about. You can go in and you can define your storage and make it available, again, like as one big pool, or not one big pool, but many pools of storage. And rather than looking at specific disk arrays and specific LUNs and specific fiber switches and things like that. Okay. This screenshot I took this morning, actually, and this is what I mentioned if you go to the TechNet Virtual Labs and just spin all this stuff up for you. I didn't have a clean environment to just take screenshots, but this was up in 1 minute. 8 virtual machines, domain controller, and one VM for every System Center product. So it's like 6 products, I think. So yeah, so I just set that up. And so here you see that you're managing stuff at a fabric level rather than at an individual server or host or storage array level. Okay. Skip this a little bit. PowerShell. There's lots of improvements in PowerShell. I think it's taken for granted because so many people use it now for management. And actually, I'll end there and actually take some questions. The conclusion again here is that there's a lot of benefits to doing this level of automation. The stragglers, the parts that are probably the pain points in your environment right now are probably networking and storage because you still have those managed manually. And so that's kind of the next logical step in truly automating the data center and making everybody live a happier, healthier lives. So thanks a lot for the opportunity to present and your attention. If you guys have any questions, feel free to ask.